Hey guys, we're going to be working on section 13.1 today. There's three main topics in this section. We're going to look at the distance formula. We're going to look at how to tell if points are collinear using the distance formula, and also the equation of a circle. So many of you probably remember, or at least it looks familiar, the distance formula from your algebra classes. We're going to take notes on this, so I'm going to go as slow as I can. If you need to pause this at any time and replay, please make sure you do that. All right, this distance formula does need to be memorized. You're looking at the square root of the difference of the x coordinates in two ordered pairs squared, plus the difference in the y coordinates of two ordered pairs squared. So when you have 2 points, you're going to designate them as x1, y1, and x2, y2. That's just so you work with organization. If you were to have two ordered pairs that form a vertical line, you don't necessarily have to use the distance formula because there's a vertical change between the 2 points. You can look at the difference, the positive difference between the y coordinates. So when you're looking at positive difference, we have to do absolute value. So you're going to do the absolute value of -3 minus 2. So the absolute value of -5. So therefore the difference between the 2 points is 5 units. It doesn't matter if you were to set it up doing -3 minus 2 or 2 minus -3, because you get the same result in the end. If you're looking at two ordered pairs that have the same y coordinate, you could do the difference between the x coordinates and take the absolute value of it. So you could do the absolute value of -3 minus 4 equals the absolute value of -7, which then is 7 units away from each other. These points are, again, because there's a horizontal line that's formed. So you can look at the horizontal change amongst the points. Again, it doesn't matter if I start with -3 or start with 4. When I go to do the difference, I get +7. Absolute value of +7 is still 7. All right, now, when the points do not form an easy vertical change or horizontal change, you need to calculate the distance between these 2 points using our distance formula. So we're going to designate the two ordered pairs as x1, y1, and x2, y2. We're going to be nice, neat, and organized with our work. The distance is the square root of x2 minus x1, quantity squared, plus the difference of y2 minus y1, quantity squared. Be careful with your integer operations. Remember, double negative becomes a positive. So we're looking at the square root of 4 plus 1 squared plus 1 plus 3 squared. Watch your order of operations. Simplify what's inside first. So we have 5 squared plus 4 squared. 5 squared is 25. 4 squared is 16. So now we have to add 25 and 16 together before doing the square root. So we have the square root of 41. Remember, with your radicals, you always want to have them in simplest radical form. So you need to consider doing a factor tree for these and simplify if possible. 41 is prime, so this does not break down. So your distance between the points -1, -3, and 4, -1 is the square root of 41 units. If that were to break down into simplest radical form, then that would be your answer, okay? Remember to always simplify. All right, now we're going to look to see how you can tell if points are collinear using the distance formula. I'm going to give you 3 points. Point A is 1, 1. Point B is -3, -11. Point C is 4, 10. I need to see if all 3 of these points lie on the same line. Now you guys should remember from earlier this year, any 2 points forms a line. So we need to see if all 3 of these points lie on the same line. So therefore, I'm going to look at the distance between points A and B, the distance between points B and C, and the distance between points A and C. I know this is tedious, but do your best. Okay, we're going to do the square root of, okay, look at your 2 points that correlate, set it up, so this way you're organized with your work. We're going to do the change in the x's, -3 minus 1 squared, plus the change in the y's, -11 minus 1 squared. We go to simplify. Okay, remember, always put things in simplest radical form. Do your factor tree if needed. Okay, square root of 160 simplifies to 4 root 10. So the length of AB is 4 root 10. Now, since I'm doing length, I'm not putting any symbols over AB. Remember, AB denotes length. Now I need to do the distance for BC. So I go to set it up with the distance formula. Look at points B and C. Do the change in the x's squared plus the change in the y's squared. Simplify. What's this? 10. Oh, sign here. Minus 11. So we get plus, so 21. So therefore 441 plus 49. That simplifies to 7 root 10. Okay, so the length of BC is 7 root 10. Now we have to find the distance of AC. So we set it up with our distance formula. 4 minus 1 squared plus 10 minus 1 squared. Don't forget to do your squares before you add them. So we've got 9 plus 81. Looking at the square root of 90, which then breaks down to 3 root 10. So therefore the length of AC is 3 root 10. In order to tell if all 3 of these points are collinear, their lengths of 2 of them have to add up to the 3rd one. So it could be in any order. So you got to look to see, can you combine these in any way? 4 root 10 plus 7 root 10, would that equal 3 root 10? No. But if I do 4 root 10 plus 3 root 10, that would equal 7 root 10. So since the length of AB plus the length of AC equals the length of BC, therefore the points A, B, and C are collinear.